All right, let's take a look and see what we got going on here. If you take a look at this box, it is a tiny spectrum analyzer, and this is the Ultra Plus. Right here, you can see it is the ZS407, so this is the latest and greatest. Now that the unboxing's done, we can get to this part. Everybody seems to like that for some reason. What we're going to do in this video is we're going to talk a little bit about this spectrum analyzer and how it's an improvement over this one. This is the TinySA Ultra. This is the 405. This is the 407. There was an interim one, a 406. I did a video on that, but I can't seem to find it anywhere. I may have lent it to somebody. This is the original TinySA, and I was super duper excited when this came out. What I wanted to do with it when I got it was test harmonic emissions on HTs, and it worked okay for that. So when the Ultra came out, I was super excited because it works much better, has a larger bandwidth and more display on the screen. I also just want to talk for a second. It is not a Nano VNA. This is a Nano VNA H4, and people get these things confused all the time. I can see why. They look similar, and their names are kind of similar, but they're very different devices that do different things. We're going to cover that as well. What I'm going to do now is I'm going to talk a little bit about spectrum analyzers, how they work, what they do, and the differences. And then we're going to do some testing with this to show how they can be useful in your ham shack. Between these two devices, let's call it $300, for a Nano VNA and a TinySA, you get a lot of RF measurement capabilities that you wouldn't have been able to get 5, 10, 15, 20 years ago without spending tens of thousands of dollars. And they compare pretty well to what I would call consumer-grade lab equipment, like Siglent and Rigel and stuff like that. They've really given hams a bunch of capabilities that didn't exist before for measuring and analyzing signals, measuring and analyzing radio performance. So let's jump into it. All right, I forgot to mention, I was contacted by a company called Aursinc, and they are a reseller of these particular products. And they asked if I would do a video review showcasing this product, and I said yes. So that means that they sent this to me free of charge in exchange for this video review. If you're the type of person who is triggered by sponsored content on YouTube, I suggest you go watch some cat videos. So I have the TinySA Ultra, this is the 407, connected via this USB cable to my computer. It's a USB-C port that comes on here, which is super duper handy. There's a couple of things that we need to do when we first get one of these to make sure that everything is set up correctly. So let me see if I got this right. Here is the actual display. I set up some software to do this. I do have a playlist that includes all kinds of things you can do with these devices, and I'm pretty sure I showed how to set up the software in that playlist somewhere. Anyhow, we are on, and what I want to do is I want to enable Ultra mode, and I'm not even sure if I remember how to do this. I think I go into the menu, and then I go into config. Okay, it's in here under config, and then I think I go down to more, and then I click enable Ultra. And it says visit for the unlock code. I think it's 1234. 1234. Enter. All right, now that we've enabled Ultra mode, what I want to do is I want to go back into my menu. I want to go into config, and I want to do a self-test. Let me turn this off real quick. Before I do the self-test, I want to take a cable. I want to take these things off. And I want to connect one end to the calibration port, and then the other one to the RF port. All right, so we got that on there. And what I'm going to do is I'm going to click self-test. Now what I want to do is I want to go back into the menu. I want to hit config, and I want to pick self-test. Now it's going to run through a self-test. If this fails at any point, you might have a problem, and that problem could even include having a fake copy or clone, so I would suggest you only buy these from authorized sources. But it's running through a series of tests right now, looking for all kinds of stuff. All right, now it says touch screen to continue. We're going to do that. And we're back to somewhat normal. The next thing I want to do is I do want to run a calibration on here. So I go to config, and I'm going to go to level cal. And I can calibrate at different levels here. Now you can reset your calibration, which is a good thing to do from time to time if you suspect something's goofy or wrong. And then I'm going to calibrate from 100 kilohertz to 7.37 gigahertz. Calibrating above that requires an external noise source, and I don't have one that goes that high, so we're not going to do it. So that means that my TinySA Ultra Plus will be accurate up to around 7.3 gigs, which is way beyond anything that I do. And I'm calibrating. There we go. I was wondering if it was going to show something on that screen. So as it runs through here, there's something I do want to mention. You don't have to do this every time you use it. This is first time use stuff, and then calibrate and self-test regularly when you do firmware updates or when you think something needs to be changed or you want to verify something. But it's not something you need to do every time you use the device. All right, now it says calibration complete. Touch the screen to continue. All right, now we're ready to make some measurements. Okay, so in order to do these tests, I want to show you something. When you go into the menu, which is highlighted right here, I got to go to the top menu. At the bottom, there's something called mode. And if we hit this mode, we have Spectrum Analyzer, which is the mode it's in now. And that allows you to measure signals that are coming into your TinySA. And then we have something called Signal Generator. Let that come up. And what this allows you to do is generate signals coming out of the TinySA. So if you take a look at this right now, it's set for low output is off. We have a frequency set for 10 megahertz. You can go ahead and change this. For example, we might want to take a look at 14 to 90 megahertz, for example. And we have a level here. So for here, we're going to do negative 73 dBm. And that should come through. That's an S9 signal on HF frequencies. Modulation, right now I have it set for none, but we could go AM or FM. It doesn't really matter. And then back here, well, it does matter, depending upon what your radio is set to and what you want to measure. But for our test, it's okay. What we're going to do is you can do sweeping. You can turn a sweep on and off. You can set sweep parameters. External gain is if you're using an LNA or any kind of attenuation to make your signal higher or lower. And then output, you have a sine wave. You can do for cleanest signal or you can do for highest accuracy. We're set for highest accuracy. And then we can come back to mode and you could go back to Spectrum Analyzer if you want. You cannot do both of these. You cannot do both of these at the same time. Okay, so we have the TinySA Ultra set up. It's connected through this blue cable, and it's going into my Yaesu FTX1 field. We're set for 14290, and we're set on continuous wave. Now, what we want to do is we want to just take a look and see what our S-level readings are. So for HF, UHF, and VHF, I have this table that shows different values. S9 on HF is negative 73 dBm. And why that's important, we have our TinySA Ultra set to transmit on 14290 at negative 73 dBm, no modulation, no sweep, and no external gain, output of a sine wave. So all I have to do to turn this on is click right here. And you can probably hear that if I turn it up. So let me go ahead and turn that off. Now I'm going to go back to the radio. Okay, so hopefully folks can see this. Now, I'm not sure what the calibration procedure is for testing the S9 signal on this radio. It's a new radio to me, and I haven't messed with this yet. But what we're going to do is we're just going to go ahead and we're going to turn this baby on. Now, I don't have any preamp on. You can see my IPO right there. But I can adjust my RF gain. Right now, my RF gain is fully clockwise. When I turn it went back to volume. When I turn it counterclockwise, you can see the S meter changing. The S meter is the top line of this chart. Let me turn the volume back up so we can hear. And right now it looks like we're just under an S6. So if I continue to turn this down, that's where I am at an S9. Now, if I do mess with my IPO and my preamp, which I don't like doing, you can see that it's not changing at all. Now, if I go back to my RF gain, let's say we turn it all the way up, and now I mess with my IPO, you can see that it does indeed change my S level. So I really have to figure out how the S meter works, RF gain works on this radio. Yeah, I haven't used this type of Yaesu in a long time, so I'm still learning it. So the point of it is that I can use the TinySA to inject signals into my radio and do some analysis. Okay, so what we have here is an attenuator, and we talked about those a little bit, or we're going to talk about those. I think I changed the order of the video a little bit. But my buddy was asking me if he could test his attenuator. Now, normally I would say you test that with a nano VNA, it's a preferred tool, but he does not have one. And so I said, well, let me see if we can figure out a way to test this with the TinySA. And so if I connect my TinySA cables that came with it to my device, and then I take my attenuator and then I just put this in line, I'm going to have to use the barrel connector that came with it because the way that my adapters work here. Okay, so we have the attenuator in line with the TinySA. Now what I'm going to do is I'm going to switch to the screen where you can see the TinySA a little bit better. Okay, so now we have everything connected through the computer. I'm going to hit mode. And when that happens, I can pick right here, calibration output. And here I can test at various frequencies my calibrated signal that comes out of the top port, and then the calibration port on the TinySA, and then into the RF port. And let's just go ahead and pick 30 megahertz. And now if I go to spectrum analyzer mode, and let me narrow my sweep a little bit, I can go into frequency, and let's do a start frequency of 20 megahertz. And then a stop of 35 megahertz. Okay, so what you can see here is that we are producing a signal, and the signal says negative 45, 46, 47. Right now it's 45 dBm at 30 megahertz, and that's what we want to be taking a look at. So that's with the attenuator in line. So what I'm going to do is I'm just going to remove the attenuator. When I do this, we should get a dead signal. And then I'm just going to connect those two coaxial cables back together without the attenuator. And then you can see that we are at 39.7 dBm. So what that would tell you is that this attenuator was attenuating at a particular, I don't remember what it was at. And here we go. And if we look at our attenuator, it is a 10 dB attenuator. So it's not measuring quite 10 dB, but it lets me know that the attenuation does work and what the exact values are with this configuration. All right, so let's play around a little bit more. So we're back connected to our Yaesu. And what I want to do is I want to take some signals out of the Yaesu, and I'm going to feed them through an attenuation network that I have here with my big ass attenuator at 40 dB. And then a little ass attenuator at 30 dB. So that's negative 70 dB of attenuation. So what I'm going to do is, where's my dang old mic key? If I key up, does it do anything? It does do something. I guess it's transmitting on CW. Let me pull the TinySA up on the screen. Okay, so you should be able to see the TinySA there on the screen. Let me get this keyboard out of the way. And let's play around with these signals. So what we want to do is we want to take a look at this carrier signal. And let me go in here and take a look at my frequency. And that was at 1490. So let's do a start of 12 megahertz. And let's do a stop of 15 megahertz. And that should be able to let us see what's going on in here. And there's our signal, and it is at 142906, and it's reading around 31.8 dBm. And let's do this. Go in here, and I'm going to go to back, and I think it's in display. No, my memory's fading on me. I think it's in level. External gain negative 70 times 1. And so what that does is it just sets a configuration setting for our external gain. Now, when I key up, it should give us a truer reading. I don't even know what this thing is set to. Okay, it says 38.2 dBm. It's a 6-watt radio. Around 37.5 is 5 watts, so that looks about right. So as you can see, we can key that up, and we can get a signal strength reading here in dBm. Well, you might say, hey, man, I'm not real good at dBm. So you can actually change this. I can go to unit, and I can pick watts, for example. Now, this looks like a mess right now, but once we key it up, it should sort itself out. But you can see in the upper left-hand corner there, it's showing us at 6.588 watts is what it's reading. So you can toggle between dBm and watts if that's a challenge for you. Now, I want to get out of watts and make this thing a little easier to read. So let me click on here. I'm going to go back to unit, and then I'm going to go to dBm. It's a good idea to work with dBm, so it's just a little easier all the way around. Okay, once that's settling down, let's see if we can change this thing on the radio. We're in CW. And let's go to AM. Okay, now we're on the AM. Let's key up and see what happens here. So we have our AM signal there, but we can't really discern too much. And we're still at 14,290, so let's go back into our device. We're going to go back, we're going to go into frequency, and we're going to do our sender frequency of 14.290 megahertz. So this should put that frequency right smack in the center of our screen. So I key up, I can see it. Let's do this. Let me go in here and go to span, and let's do 100 kilohertz. So this is really going to allow us to focus on that signal. So when I key up, we should be able to see it in more detail. And I really can't see it in too much more detail. Let's go back and do span of 50 kilohertz. Okay, so what I've done is I've changed the span to 25 kilohertz to make it a little bit tighter, and then I'm going to come down here to resolution bandwidth was set to auto. So take a look at the green bar on the bottom. If I put it back on auto, see how slow that green bar moves? If I come down here and I change my resolution bandwidth, I can move it to, say, 1 kilohertz. Now we're going to key up. We should see this thing in a little bit more detail. So you can start to see the form of our AM signal. And what happens if I talk in here? Does it make any changes or do anything differently? Look at that. It makes it a giant mess. Okay, one other test that we want to do is we're going to take a quick look at harmonics. Now, I'm not going to go through the whole harmonics test configuration because it's a giant pain in the butt. But if I go back to my main menu, I can come down here and go to measure, and I can pick harmonics. And our frequency is 14.290 megahertz. And then I set my span for each one of the segments that it's going to look at harmonics on. And let's just go with 1 megahertz. That should be plenty. So you can see my TinySA, when it comes on, has divided the screen for each harmonic interval with a vertical blue line. Each one of those blue lines represents 1 megahertz of bandwidth. So if we go ahead and we key up, we can see our fundamental frequency. Now we're using AM, keep that in mind. Number 1 is our marker, and it says 14.89 megahertz. We're 14.290, but that's good enough. And it's giving us around 35, 36, 37 dB. Right now it's saying 34.5 dB. But that would be our spurious emissions or harmonic test if we were looking at that. All right, let's talk a few minutes about these devices and what they are. And I'm just going to refer to them generically as handheld spectrum analyzers. And what they are devices that allow you to, in real time, observe signals. And the formation of that signal, the strength of that signal, the behavior and the performance of your signals. These devices come often with a signal generator. All the TinySAs do. So they're capable of generating output signals. And we use those output signals to maybe run through a filter, and we can characterize that filter. Maybe we want to inject a known signal into a radio, take a look at its S meter, or calibrate or align that radio to that particular frequency. It's really helpful. As I mentioned, there are a couple of different models. The TinySA, the normal base model, is good for beginners. When I bought mine, I wasn't overly impressed with it. Part of the challenge is, and I got it right here, so let me show you. It has 2 inputs on here, and what it has is that one goes up to 350 megahertz, and I think the other one goes to 900 megahertz. So I couldn't look at a sweep all the way through, DC to 900 megahertz without having to change the screen, and I didn't like that. When the Ultra came out, I could do that, and I was super duper happy with that. And then we mentioned with the Ultra Plus, this particular version, we can go up to 7.3 gigahertz. Way, way beyond anything I do as an amateur radio operator, but there might be some of you out there that are doing those types of things. But the big thing is that these are small, they're portable, you can connect them to a computer, they're reasonably powerful and accurate and affordable. So some of the key benefits and capabilities of these things is that, you, as I mentioned, you can do real-time spectral analysis, HF, VHF, Wi-Fi, and you can even go into ISM and higher into microwave bands. We talked a little bit about the integrated signal generator, and what's nice about that is you can do AM modulation, you can do FM modulation, you can do square sine waves, and they go up to different frequencies where some of those capabilities cut off. But it's really helpful. I test the front end reception capability of HTs to verify that they're as sensitive as they say, and then I also test adjacent signal rejection capabilities of HTs using two of these with a combiner, which is super handy. I mentioned the Ultra and Ultra Plus go up to pretty high frequencies. They have a touchscreen interface, super duper easy to use. So people say, well, if I had one of these things, what would I do with it as an amateur radio operator? So I have a couple things listed here. Filter testing, which is something I do all the time, taking a look at high pass, low pass filters, band pass filters. I've even taken a look at some notch filter stuff. I've had to build some filters to suppress harmonic emissions, and I've used it for that. You can look at bandwidth of the filters. You can look at insertion loss. You can do all kinds of things like that. I talked a little bit about transmit and receiving alignment of your radio. That's a pretty powerful capability. The other thing is that you can use it to look for interference in your house, anything that could be causing any kind of noise or increase in your noise floor. So people, they come with an antenna. I think I showed that when I tore everything out of the box. We'll hook that antenna up and they'll go hunting around and see if they can find anything, like maybe your washing machine, for example, is generating noise. This will help you track that down. Also, with that antenna, you can kind of use these things as a field strength meter and walk around your antenna, test for directionality, front-back ratio, things like that. The other thing is that they are lightweight enough that you can take them out into the field. You might say, well, Ape, why would you take one of these out in the field? What are you going to do with it? Really where it helps is if you're trying to do any kind of signal hunting or for interference detection or any kind of field strength measurements of your antenna. So talking a little bit about the comparison of the different models, the basic covers up to 350 megahertz in high quality, and then 960. I think I said 900 earlier for lower quality. They're decent, but I got to just being honest. When anybody asks me about buying one of these things, I say at a minimum get the Ultra. I would get one of the Ultra Pluses, probably the 407, the highest end one now that it's available. The Ultras offer better dynamic range, lower noise floors. They have larger batteries, and they have improved filtering. These things do come with preamps. They come with attenuation capabilities, which is pretty handy. And we're going to talk about resolution bandwidth and video bandwidth coming up. These things sometimes require some accessories. Most of the time they do. And this ensures safety, accuracy, and the quality of your signal. The input of the TinySA is only good for around 6 dB. Anything higher than that, you could risk damaging your TinySA. It does its best measurements at around negative 25 dB or even lower. So what I recommend is that at a minimum, get a 30 to 40 dB attenuator. I actually attenuate even more than that when I have an input signal coming in. So if I'm testing like a 5-watt signal, I'll do about 60 dB of attenuation. So attenuators are important. The other one is that the higher quality SMA cables that you have, so the ones that come with it are pretty good, but you might want to look at something made out of like a quality RG316. That way you don't have any loss in your cable, no signal degradation from that, and you have quality and consistency. Also, you may want to use dummy loads if you're measuring over-the-air signals, not a direct connection through a coaxial cable. Like you may want to transmit an HT or even a desktop radio into a dummy load and then characterize that signal over the air. They call that air gapping with an antenna connected. The other thing is potentially low noise amplification. So I have some videos on low noise amplifiers in my TinySA playlist where you might have a signal that's super duper low and you want to be able to characterize that a little bit better. So by applying some amplification via a LNA, you can see that signal a little bit better. So I mentioned at the beginning of the video that there are some differences between the TinySA and the Nano VNA, and what we're going to talk about here is the measurement focus. So TinySA takes a look at signal strength versus frequency. It looks at signal quality and it enables you to look at the signal itself, the characterization of the signal itself. The Nano VNA measures S parameters like reflection coefficient, insertion loss, and gain. There is some overlap in what you can do. There's some measurements you can make with both devices, but they're really different. So I typically use the Nano VNA to characterize things like a coaxial cable or a filter or an antenna. And I typically use the TinySA to characterize the signal itself. So the frequency coverage, the TinySA Ultra Plus, the 407, it has a higher bandwidth than any Nano VNA that I've used at this time. It is going back and forth as to which one has a wider bandwidth, but right now the Ultra Plus 407 is the clear winner. The Nano VNA does have what's called a real-time tracking generator, and that means that it transmits and receives the signal that are coordinated, that allows you to go through a particular device. And it's super handy. Higher end spectrum analyzers have that as well. The TinySA does have a signal generator, but it cannot operate the same time that you're doing spectrum analysis. So it does not have that, what's called a tracking generator. So then ideal applications, I had the TinySA excels at signal hunting, emission checks, spectral sweeps. The Nano VNA is perfect for testing antennas, filters, and things like that. So I just want to talk a little bit about resolution bandwidth and video bandwidth. So resolution bandwidth controls the frequency resolution. When you look at narrow resolution bandwidth, it allows you to see closely spaced signals. So if you're looking at two signals that are really close together, by controlling that resolution bandwidth, you might see both of them, or you might just see one signal if it's spaced too far apart. Video bandwidth is really smoothing of the display line. So sometimes when you're doing signal characterization, you have to adjust both of those to get what exactly you're looking for. Markers are super helpful because they allow you to mark a particular frequency and see how it behaves when you modify something under test. So if I have testing, let's just say a variable filter, as I test that, I can quickly look at that marker and see where my signal levels are. It does have logging and it has average modes. Average modes are really handy if you have a rapidly or fast changing signal. It allows it to kind of, you can do, I think, do up to 16 times averaging, which makes the frequency line a little bit more stable. So in terms of these models, everybody's going to want me to do some sort of recommendation. And TinySA Basic, if you want to learn, you want to characterize some signals and you're mostly operating down below 350 megahertz, you can get that one. It's not my preferred TinySA. I really do like the TinySA Ultra. It goes up to 4.4 gigahertz in terms of signal generation. It works really well for UHF and VHF diagnostics. Great for HF. Larger screen. The Ultras, which is the 406 and the 407, they give you more bandwidth, higher signal generation capabilities. They have better filtering. They have better dynamic range, and they have the lowest noise floor. That would be my recommendation, the 406 or the 407. When we talk about best value for ham use, the Ultra and the Ultra Plus models offer unmatched price performance. Definitely the ones that I would recommend.